Now, I've added some stuff up here. I don't want you to look at it unless you've already attempted to work the rest of the problems on the document. If you have, then I gave you some highlights, some things you might have missed, some things you should know. And of course, I give you the results. So you need to look at what I have to say about all this and see if it matches what you've done in solving the rest of the problems. Now, if we do the difference quotient on S of t, and I haven't gone through the details of this, we went through the details of a number of calculations of this nature, but the derivative is the limit as delta t goes to 0 of S of t plus delta t minus S of t divided by delta t. Now that corresponds very closely to many of the calculations we did over here, but we did them with 2 instead of t, and we used 0.01 instead of delta t, so that we didn't get a general formula, we just got a specific result that corresponds to t equals 2 and interval of 0.01. So if t was 2 and delta t was 0.01, if we did this, we would end up doing exactly the same calculations we would do, or we have done here. The result of this calculation, once you simplify all this, a lot of stuff in the numerator will subtract off, and you'll end up with a delta t dividing a bunch of terms, all of which have delta t's or delta t squareds, and in general, with a polynomial, you'd have other powers of delta t as well. When you divide by delta t, the numbers that just have, or the quantities that just have coefficient delta t, the delta t will divide out, and you'll just have the coefficient of that quantity. When I should have said, when you have a quantity of some coefficient multiplied by delta t and divide by delta t, you're just left with that coefficient. And that's where the 0.06t comes from. Now, you're not going to understand this unless you write it out yourself, but I'm giving you some highlights here, and I recommend that you do write this out, having been through this, so you more completely understand the connections. You'll also have a term with coefficient 2. You get a 2 delta t in this numerator, and when you divide by delta t, it gives you 2. All the other terms have higher powers of delta t, so that when delta t divides into them, there's at least a delta t left. And as delta t goes to 0, of course, all those terms are going to disappear. Again, you need to work this through, look back through examples if you want to completely understand how this derivative expression is obtained, other than by using the power function rule, and how it corresponds exactly with what you get down here. The other thing then is that there are a couple of other questions that are posed on the document. One is to evaluate S of 2 plus h. Now, here's where people are making serious errors, okay? People want to say S of 2 plus h is S of 2 plus h. So you plug 2 into this thing, and then you tack an h onto the end. That's not what S of 2 plus h means. S of 2 plus h means you take the S of t expression and replace t with 2 plus h. And if you do it S of t plus delta t, S of t plus delta t is not 0.03 t squared plus 2t plus 9 plus delta t. S of t plus delta t is what you get when you replace this t with a t plus delta t, meaning you have to replace these t's with t plus delta t. If you don't do that, you're not going to get the right thing. So anyhow, down here, if we replace t with 2 plus h, 0.03 t squared becomes what? 0.03 times the square of 2 plus h, which incidentally is not 4 plus h squared. You square that binomial. And if you're careful, everybody knows how to do that, but people are still writing down what they think it ought to be rather than working it out. You really need to work that out. Okay, 2t becomes what? You're replacing t with 2 plus h, so 2t back here becomes 2 times the quantity 2 plus h. Now there's no t in the 9, so the 9 simply remains. When we expand this and expand it correctly. If you don't expand it correctly, you're not going to get the right answer. We expand this, and then we evaluate this numerator, s of 2 plus h minus s of 2. Okay, well, the expanded version of this contains all of this, okay? Or everything you would get here if t was equal to 2. So a lot of stuff is going to simply disappear, and you're only going to be left with 0.12h plus 2h plus 0.03h squared. Now you have to work that out. I'm not going to work that out for you. You have to work this out and verify that you really get this. And if you're absolutely convinced that's not what you get, let me know and we'll see if we can get it straight. I can make mistakes. You see me do it all the time. Don't think I've got one here, but could be. Okay. And then you're asked to evaluate the limit as h goes to 0 of s of 2 plus h minus s of 2 over h. And all I'm going to say is that s of 2 plus h minus s of 2 is going to simplify, well, simplifies down to what you see here, so that when you divide this by h, you get 0.12 and 2. Okay? Both of these terms. This term gives you 0.12, this term gives you 2. And then you're going to get a 0.03h when you divide 0.03h squared by h. The result then is, and I'm missing a set of parentheses here, and don't have a lot of room to work them in, but let's see if I can. So, this expression here becomes 2.12 plus 0.03h. Again, you're just dividing this by h, and it looks like I included the h here, so I should have included it here. Okay, when I say it's right, I mean that numerator was right. I left out the denominator. Okay, so again, we can see very easily when we divide each term by h, we get 0.12, we get 2, that adds up to 2.12, and we have 0.03h, which I've got here. As h approaches 0, 0.03h approaches 0, and we're just left with the 2.12. And of course, 2.12 is the value of the derivative when t equals 2. Now, you should work everything through, and hopefully you did work everything through before you look at what I have here.